Hello, welcome all of you. So, in today's video, I'll be discussing one question which has appeared in GATE Life Sciences 2013 question paper in biochemistry section. This is question number 19, and this question is related to enzyme substrate uh, reaction, but majorly this question will be solved according to the calculations of conversion of molarity to concentration and molecular weight. This will revolve around that. So this question reads as: the enzyme of 40 kilodalton is added to a substrate solution in a molar ratio of 1 is to 3. The concentration of enzyme in the mixture is 12 mg per ml. What would be the corresponding substrate concentration? So here they are performing an enzyme and substrate reaction. So suppose one tube that has a substrate. So they are performing a reaction. Here they have a substrate, and here they'll be adding enzyme in this reaction, and that they have told the ratio they have used is 1 is to 3, and also it has been mentioned it is a molar ratio. So that means molarity wise it is 1 is to 3. So which one is 1, which one is 3? So if we'll see, it has written first enzyme added to substrate in a molar ratio of 1 is to 3. So first it is written enzyme. So this 1 will be enzyme and 3 will be substrate. That is the ratio they have used. 1 enzyme to 3 substrate in molar ratio. Okay, and about the enzyme's property, they have said that it is 40 kilodalton enzyme, and the concentration of enzyme in the mixture is 12 mg per ml. Okay, so this enzyme which they have added, it is a 40 kilodalton enzyme. Only molecular weight they are saying, and here they are saying whatever they are telling, it is the concentration of enzyme is 12 mg per ml. Okay, so here it is 1 is to 3 enzyme versus substrate. Enzyme they have used 12 mg per ml, and substrate concentration they need, and substrate concentration they need in molar, and enzyme as it is a molarity ratio, so we need molarity of enzyme versus molarity of substrate. Okay, but the enzymes amount is given in 12 mg per ml. So here final concentration is 12 mg per ml. How much molarity they have used, it is not mentioned. So we have to find out how much, in what molarity the enzyme has been added, and then molarity of the substrate can be found out. So the our reaction or the basic equation becomes molarity of enzyme as the molarity of substrate is 1 is to 3. 1 part of molar ratio of enzyme and 3 part of molar ratio of substrate. That is our equation. So if we can, and we have been asked this molarity of the substrate. This is the question been asked. That means we should be knowing molarity of the enzyme in order to get the substrate concentration in molar. So uh, our final equation is 3 into molarity of enzyme. So we have to solve this question with this equation. Okay, so we have to find out the molarity of the enzyme. So about the molar enzyme, only two properties are given: enzyme's molecular weight and enzyme's final concentration. So using these two, we have to reach to the molarity of the enzyme. So what is the formula for that? So the formula for the, everybody should remember, This is a basic formula which will help you in all the solving all the concentration molarity related questions. So the formula is molar concentration. Molar concentration uh, into molecular weight is equal to the concentration, the final concentration. Okay, so this molar concentration, molarity is nothing but moles per liter. Okay, molecular weight we have in grams per mole, gram per mole, or we can also write in daltons because 1 gram per mole is equal to 1 dalton. So both the units are equivalent. Okay, and the concentration we generally have grams per liter. Okay, grams per liter. So this is the formula and these are the uh, units. Okay, so we have to find out the molar concentration of the enzyme. We know the molecular weight, we know the concentration as well. So in our question we have been given 40 kilo Dalton as a molecular weight. Okay, so we have, if we will see like that, it shows 1 Dalton is equal to 1 gram per mole. Okay, or here we have to write the value in the Dalton. So here our molecular weight is 40 kilodalton. So we have to convert it to Dalton, that is 40,000 Daltons. That means 40,000 gram per moles according to this one. 1 Dalton, 1 gram per mole. 40,000 Daltons, 40,000 grams per mole. Okay, and the concentration that we have is 12 mg per ml. So here we have one value in grams per mole, one value in mg per ml. So we have to find out, like we have to keep only one unit only. So let's change this one. So this gram per mole can also be written as 14 to 10 to the power 3 g per millimoles. Okay, it can be written like this, milligram per millimole, because gram per mole can be written as milligram per millimole. So now we have the molecular weight and the concentration both in the same units. Using this we can find out the molar concentration of the enzyme. Okay, molar concentration of the enzyme. So this will come as if we calculate molarity is equal to, so molarity is equal to, we'll have concentration upon molecular weight. We have concentration which is 12 mg per ml, and 40 into 10 to the power 3 mg per millimoles. So this is the formula for, this is the enzyme's molarity, okay, which we need to solve. So if we solve this, we'll get the value we'll get 0.3 into 10 to the power minus 3 mils per ml. Okay, millimole per ml, or we can just write molar, which is the molarity. This is also called as molarity. 0.3 into 10 to the power minus 3 molarity, or we can also write 0.3 millimolar. Okay, so this is the molarity of the enzyme we got from here. Now our form equation was this. To find out the substrate concentration, it will be 3 times of the enzyme's molarity. So enzyme's molar concentration will be Ms is equal to 3 into enzyme's molar concentration, which is 0.3 millimolar. So our answer will be 0.9 millimolar. So this is the molar concentration of the substrate. So here if we'll see out of the 4 options, the third option, which is 0.9 millimolar, which is the correct option. So this is how it will be solved. Basic formula. This needs to be remembered. My NPTEL reference.